गुड मॉर्निंग दोस्तों, मेरा नाम सुरेंद्र कुमार है और मैं अजय कुमार इंजीनियरिंग कॉलेज में असिस्टेंट प्रोफेसर पर हूँ। मेरा डिपार्टमेंट है सीएस डिपार्टमेंट। सो आज हम बात करने वाले हैं बूलियन अलजेब्रा के बारे में। सो बूलियन अलजेब्रा बेसिकली एक आपके पास में एक ऐसा अलजेब्रा है जो बूलियन फंक्शंस को सिंप्लीफाई करने के काम में आता है। सो सिंप्लीफिकेशन ऑफ बूलियन फंक्शन, फॉर दिस पर्पज वी यूज बूलियन अलजेब्रा. So next we will discuss here the unit 2 part. It is unit 2 part where we have two kinds of information functions and Boolean algebra. So as today we have Boolean algebra topic, so we will discuss here. So what is Boolean algebra basically? So Boolean algebra is the category of algebra in which the variables values are the truth values. Truth values means true and false value, or you can say it is 0 and 1 representation of any value. So it is also called a binary algebra. Generally we have called it binary algebra or logical algebra, or you can say switching algebra. So these are the different names of the Boolean algebra in your subject. So let's discuss from where the Boolean algebra come from. So Boolean algebra is a type of algebra that is created by operating the binary system. So how it is given by George Boole in 1854. That was an English mathematician who proposed this algebra. So this is a variant of Aristotle's propositional logic that uses the symbol 0 and 1 as a true and false format. So Boolean algebra is concerned basically with the binary variables and logical operations. So the fundamental in the development of digital electronics system, as they all use the concept of Boolean algebra to execute the command. So apart from the digital electronics, this algebra also finds its application in set theory, statistics and other branches of the mathematics. So Boolean algebra, let B be a non-empty set with two binary operations and dot, plus or dot, and a union operation not. So B contains at least element denoted by 0 and a greatest element denoted by 1. So you can represent it as B, comma, plus, comma, dot, comma, 0, 1 and not operation. This kind of structure is called a Boolean algebra, and it satisfies the following axioms, that like commutative property as in simple algebra, distributive property, identity property, complement law and all difference law. Now how the algebraic manipulation of Boolean expressions is done. So consider a Boolean algebra B containing these three operations and, or and not on value 0 and 1. So Boolean expression over Boolean algebra B is defined as every element of B is an Boolean expression. Every variable name is a Boolean expression, and if A and A1 and A2 are two Boolean expressions, then A1 or A2, A1 and A2 are again Boolean expressions. Example, 0 or 1 is a Boolean expression, 2 and 3. So these are the all Boolean expressions. These are the logic gates which usually used to represent these expressions. These gates helps to design a circuit with the help of Boolean expression. So this is the AND gate, OR gate and NOT gate. And you have already studied or discussed the truth table of the OR gate, that is A plus B. It is represented by A plus B, or it is true for all except 0 0. So here this is the truth table of the given OR gate. Same for AND gate, it is true only on 1 1 except other all are zeros. This is the only one where you have 1 output. So I think this is very simple. Already you have studied this kind of tables with the help of AND gate. This is NOT gate. It is basically complemented the property of the given input. So 0 will be converted to 1 and 1 will be converted to 0. This is NOT gate. So simplification of Boolean function and implementation of Boolean function require the use of logic gates. So use of logic gates should be minimized with the help of these Boolean functions should be simplified. So these simplification is done with the help of two methods. Then these two methods are algebraic method by using identities or the properties of the Boolean algebra, and the second method is graphical method. This is Karnaugh map method. So here we are going to discuss K-map method for simplification of Boolean functions. So K-map basically is a map having, K-map is used for a function having n variables. So if a map has to be created for a function which is of n variable, so total number of cells will be there 2 raised to the power n cells. For example, if you have two variable function f a and b, they are two variable in a function, so total number of cells will be 2 raised to the power 2, that is 4 cells. And the same way, if it is a 3 variable, it will have 8 cells, and if it is 4 variable, it will have 16 cells, 2 raised to the power 4. So what is K-map exactly? So Karnaugh map is a diagram that can be used to simplify a Boolean algebra expression. Maurice Karnaugh introduced this in 1953 as a refinement of Edward W. With chart in 1952, he given with chart. So it is also a discovery of Alan Marquand's 1881 logical diagram. So it is called Marquand diagram. So it is also useful for understanding the logic circuit. So K-map are also known as Marquand-Which diagram. Yeah, so what are charts, right? So a KV map, Karnaugh-Which map. These are different names of the K-map. So Karnaugh map basically reduce the need for expensive calculations by taking advantage of humans' pattern recognition. So this is the basic idea by which the K-map is generated, because human is easy with the graphical pattern representation. It can easily recognize the graphical patterns. So calculations are minimized with the help of this K-map. Also, it permits the rapid identification and elimination of the potential race conditions. So किसी भी K-map को बनाने के लिए we require a truth table that is in 2-dimensional grid, and the truth table is basically ordered with the help of gray code, right? So gray code is a code where we have other than binary numbers. So it is different kinds of binary format of a given number. Before that, the K-map uses SOP and POS representation of the algebraic expression. So SOP, any sum of product expression, can always be implemented with the help of AND gate and feeding into an OR gate. In the same way, a POS, any product of some expression, leads to OR gates feeding an AND gates. So here you can have these kind of AND gates, and these AND gates will be feed into OR gate. The final expression will be like this. And for POS, this is SOP, and for POS you will have different OR gates, and this will be feed to the AND gate like this, right? So we will discuss how the K-map is created. So for as you have given different kinds of notation for the Boolean function. If you find this kind of notation in Boolean function, so it is called a min term format of the given function. If you find this kind of notation, you will say it is in max term form of notation. So in min term, the 1 is considered in place of the number in the K-map. That means these are the truth values containing 1, and for POS format min max term, these are the truth value 0 for the given numbers, or you can say it is complemented. If you convert it in different format, so it is complemented format. So min term I have discussed ki where it stands for 1, it is a min term. Where it stands for 0, that will be max term. So small m is considered as a min term and capital M is considered as a max term. Now we have this kind of representation using K-map. So K-map basically a two-dimensional structure which is which shows the adjacency of the cells are adjacent to each other, and those adjacent cells are combined in a group and the expression is reduced. So these are different forms. This is a 2D form, this is a 3D form of the K-map. And how the K-map is created with the 2D to 3D, this is the representation with the help of this GIF. You can say the 2D is fold, and then again this pipe is connected with a round circle or pipe. So this is the representation of the K-map. How the grouping is to be done, or how the adjacency is find out. So this is the finding of adjacency, how you can find the adjacency of the given cells. I hope all of you have understand the structure of the K-map, how it is designed, how it is created. So the numbering of the cells is done with the help of gray code. So gray code basically is a minimum change code, or it is a wrap around code. So minimum change means a 1 bit change at a time, not more than 1 bit. So it is differ by only 1 bit. K-map differ from one another by only 1 bit. So how the gray code is created? So for n equals 1, minimum change, or you can say the mirror code also, it is a mirror code also. If it is 0, it is 1, then again it is 1 and 0. So it is a kind of mirror code. You can check here also, different bits are as a mirror code. This is the mirror code of this, and this is the mirror code of this. If you go for n equal 2, if you go n equal 3, again you can see this is the mirror code of this. You can mirror by this, right? So this is one kind of gray code, right? The other binary code and corresponding gray code of the given binary number. So it is 0 0 0 1 1 1 for 2 number, it is 1 1, for 3 it is 1 0. So how the gray code is generated? So here is the steps. We determine how many bits are required to represent the number. Then every time a bit is being changed. How the bits are changed? So case the most important portion of the proceeding code 00 will now be changed until all the codes cannot be nuclearly identified. So we repeat the process. How the process is repeated? It is shown in this chart. For example, if you have 0 0, so this 0 0 is copied to the previous code and change the 1 bit. MSB is changed. So here MSB is changed. So this is a new number. So we will remain with it. Then this number is copied to the previous code 001. Again change the bit MSB. MSB change करने पर you will find the same number as previous. So it is discarded So again it has to be copied to the previous code or change the second MSB. Now we have changed this second MSB 1. Now this is a new number. Now this is the second MSB, right? Again copy this to the previous code and change the MSB. You will find a new number. So here you can find the first 4 gray code. Again copy to this previous code and change the MSB this. So you will find 00. It is already given, so it is discarded. Sorry, it is discarded. So it has to be again copy and changed. It is also the same number, it is discarded. In the same way, again the same number will begin, again it has to be changed MSB. So now we will change MSB this one. So you will find a new gray code. In this way you can generate your gray code. I hope you understand this. Application of gray code are encoder, decoder, analog, digital to digital to analog converter, error detection code, and there are a number of significant applications are of gray code. The main is K-map, and K-map is solved with the help of gray code. Or the K-map we can solve 2 variable, 3 variable, 4 variable, 5 variable and 6 variable and so on. But as you go for above the 4 variable, the K-map is being difficult to solve. So that is why we avoid it for 4 variable. We have another method for Mac class skip it method that is used for solve more number of variables, Boolean functions. So rules for minimizing in the K-map. So simple rules are there. We create n cells, 2 raised to power n cells for the given number of variables. Put either 0 or 1 as per the requirement of SOP or POS. So we start it with the 2 variable K-map. So here the 2 variable K-map, or how we can number the cell. So to numbering the cell, we have 0, 1, 2, 3, right? So there is no problem. You can say 0, 1, 2, 3 in this way. You are numbering the cell. So this is the code, or you can write 0 for here and B for here, that is B bar, this is B, this is A bar, this is A, right? Or this is a blank map. If you have 2 numbers, a function having 2 ones in the given map, so how we can combine these 2 ones by the help of pairing. So how we can convert this into Boolean expression? So Boolean expression is, this is your, we check the no change in bits. So if we go for A is changing from 0 to 1 here by moving this way. But if you say okay, by moving this to this, B is not changing, so the expression will be B. The new function will be B. So earlier we have 2 min terms, now we will find only one term here by solving the K-map. Or you have to maximize the pairing of the given numbers. So as you see here is single one number is, so we can combine 2 numbers here in this way by overlapping. So we can use this one to combine with this one, right? Or if we have all 4s, then we will have this squared, and this squared will give you f equals 1. The value of the function will be equal to 1. This is your complete disjunctive normal form, right? So if we go for 3 variable K-map, we have 3 variables, so 2 raised to the power 3 cells, that is 8 cells. We have designed these 8 cells in this way. So A variable is this side and B, C, 2 variables are horizontally this side. So this can be represented as B dash C dash, B dash C, B C, and this is B C dash, and this is A dash and A, right? Or you can number these cells 1, 2, 3, 0, 1, 2, 3, राइट. सो एक बार आप इस साइड चलेंगे ऐसे और एक बार आप इस साइड से चलेंगे 2, 3. इन द सेम वे 4, 5, then 6, 7. This is the trick how to write the cell numbers, but actually these are the gray code. So sequence is 0, 1. This is 1, 1 and 1, 0, right? So don't confuse with the binary number or decimal number. It is a gray code representation and it is converted into decimal format to just recognize which number cell it is, because we give the mean terms as M0, M1, M2, M3, right? So we should know where the one has to be put. If we use this kind of 3 variable map, so we can have different cases for this, how to combine, how to solve the given function. For example, if we have a function having 0, 1, 2, 3, 5 terms, so on 0 we will write 1, on 2 0, 1, 2, यहाँ पे आएगा 0, 1, 2, 3, 4, 5, 6, 7. So you can see 1 पर 0 पे 1 लिखेंगे आप, 2 पर 1 लिखेंगे, then 3 पे लिखेंगे, then 5 पे लिखेंगे. So in this way your given function is represented. Now how we can simplify this K-map? So this K-map is simplified with this, with कि हम यहाँ पर 2 को कंबाइन करेंगे. यहाँ पर ये सिंगल है लेकिन वी कैन यूज फोल्डिंग लॉ. You can fold this map in this way. So these two cells will be conjugative cells, adjacent cell. Here we don't have any folding law, so it will be a single element, right? So in this way we can have 3 terms, 1 term, 2 and 3. These 3 terms has to be simplified. How? First term हम क्या लिख सकते हैं? फर्स्ट टर्म को लिख सकते हैं, we will see no change. No change is a bar. Here we say a bar. 0 को हम a bar लिखेंगे. Now we will see this digit is not changing, b. So it is b. Because it is a DNF format and is SOP format, so we will add plus here. Again we take the second term, that is here no change is again a bar, and we see C bar is not changing digit, C bar. The third one, because it is single bit here, so we will see this is A, and we will see this is B bar C. So this is a simplified expression of the given K-map. So we can have again different options, like we'll see another case. Another case, for example, we have 1 in different place. Let 1 एक यहाँ पर है, एक यहाँ पर है, एक यहाँ पर है, एक यहाँ पर है, एक यहाँ पर, एक यहाँ पर है. So how we can group these bits? So as I already have told you, we must have maximum number of ones. So maximum number of ones कैसे हो सकते हैं? 2, 4, 8, 16, right? So here we can combine 4 bits, but if you find here are only 2 bits. So these 2 bits can be again use these 2 bits. So in this way we can make it of 4 bits group, right? So this is first group, this is second group, right? So what is the expression for this simplification? It will be, for first we have no change, A is changing, but here we see B bar is not changing, so the expression is B bar. For this one, again A is changing, but C bar is not changing, so C bar. So this is the expression for the given combinations, right? So here we have a number of situations or cases by which we can represent our simplification of using K-map. Now, if we have this one also, so we can write it, we can use it as a third group. This is third one, quad, right? Or if we have all ones, so this function will be value of 1. I hope this is 3 variable K-map is clear to all. Next, this is 4 variable K-map. How you can write the cell number of 4 variable K-map? This is 0, 1, 2, 3, 4, 5, 6, 7, राइट। जब हमने इतना कर लिया यहाँ से यहाँ, तो यहाँ तक हम चले थे, अब हम इसको यहाँ से लेके चलेंगे, इसलिए यहाँ से स्टार्ट करेंगे 8, 9, 10, 11, 12, 13, 14, 15, right? So in this way you can mark the cell number in your 4 variable K-map, and 4 variable K-map will contain 2 raised to the power 4 cells, that is 16 cells, right? Now, so this is a 4 variable K-map. You can have different kinds of variables, x, y, z, or w, x, y, z, whatever you want, it can be changed, and these are the min-term format of the given cells. This is the 5 variable K-map. You can use 2 4 variables, right? You can use 2 4 variables. For example, A, B, C, D, E, 5 variable map. So you will use B, C, D, E, and for A equal to 0 and 4 equal to 1. So B, C, D, E के लिए 4 4 वेरिएबल आप दो K मैप बनाएंगे 4 4 वेरिएबल का, the same variables but changing with A equal to 0 and A equal to 1, right? So this is 5 variable K map. In the same way you can have 6 variable K map by using 4 variable K map. So you can have the 4 variable here, right? This is 6 variable K map. So as in the previous slides I have discussed, okay, if you have SOP format, this is SOP format. So by taking its complement or applying De Morgan's law, you will give a POS format. So this is a POS format. So the other steps, different min terms of the given, how you can convert into min terms these variables given in your function. For 0 0 you can write all zeros, A0, B0, C0, D0, E0, and 0 is represented by bar or complement way, right? For practice you can have a blank K-map of 4 variable, and you can use different cases. For example, I have these ones and these ones. So these one can be combined, these 8 ones all can be combined with the help of folding law. So we will use combination of 8 bits, and this can be represented as no change. We will check no change, all the bits are changing, so AB will not be there. So what will be there? We will see D is not changing, so the answer is D bar. Value of the given function will be D bar. Right. For example, if you have 1 here also, so we will combine these 2 bits. Again 1 here also, we will combine these all 4 bits. Right. If you have 1 here also, so we will again combine these 4 bits also. I hope you understand. We have to utilize other pair also which are already used. If you have a single one, you can use different 3 groups also, right? So in this way we can generate 4 variable K-map. Thank you very much. We will cover next topic in next class. Thank you so much.